Good morning, Year 3. It's Fun Time Friday. Let's see if we can do some challenges, a bit of problem solving, perhaps a bit of reasoning as well. So this first challenge should be quite familiar to you. If you've got some dice at home, it's a really good task to do with those. If not, use your number cards again. So first of all, make yourself a 3-digit number. I've got a 1, and a 2, and a 5. Now, again, as always, you can change these digits around to any other position, but I'm going to leave the 1 in the hundreds column, the 2 in the tens column, and the 5 in the ones column. So if that's the number that I've made, it goes into that top section. And then, with that number, I have to do all these different challenges. So you need to work out what one more than the number would be. So you're adding a 1s to it. So the only digit that's going to change is this one. Then go back to your original number again, so 125, and you're going to make the number which is 1 less. So again, this digit's going to change, the 1s column, and 1 less than 5 ones is obviously 4 ones. And then your next challenge is to do 10 more than the number. So in this number, my tens number is 2 tens, so 10 more would obviously make it 3 tens, and instead of it being worth 20, it would be worth 30. So I'd have 135. Then the number which is 10 less than my original number, so if I had 2 tens, I'd only have 1 10, and I'd have 115. Now try the number which is 100 more. So again, working on that place value, I'm now in the hundreds column. So I had 100, 100 more would make it 200. So I'd have 225. Then I'm going to do the number which is 100 less than the number. So what would that be? If I removed that 100, there would be 0 now in the hundreds column. So I'd only have 25. So this is a really good challenge again of just making sure that our place value is really secure so that we can move on with everything else later. Try to do some of your own numbers. Maybe ask someone to make a number for you, or use your number cards, or if you've got any dice at home, you can make up your own number. Have some fun with it. See how you get on. Let's go on to another challenge. Okay, here's our next challenge, and it's a reasoning challenge. So there's a number chain. You can see the number chain there. Some of the circles have numbers in them. Some of them are left blank. You can see you've got 120, 135, 150, 2 blanks, 195, another blank, 225, 240, and another blank. So there's space to work out what those blanks are worth. What are the values of A, B, C, and D? And then in the challenge, you've got Kate. Kate looks incredibly happy. And she said, I think circle D is 250. So she thinks the value of the last circle in the sequence is 250. Now you have to work out if Kate's right. So think really carefully. First of all, work out the differences between the circles, and then see if you can find out the value of A, B, C, and finally D. And then can you explain to Kate? So imagine Kate's someone in the classroom, maybe the person who sits next to you. How would you explain to her whether she's right or whether she's wrong? Think about the reasoning behind it. How did you work it out? Can you help her to work it out correctly? So use those reasoning skills and explain to her fully, perhaps drawing a diagram, perhaps showing her with your sums, your calculations, to show her whether she's right or wrong. And then try some puzzles similar. Maybe you could make up one for somebody else in your house, or maybe ask someone in your house to make up one for you. Let's return to the problem. Now it's really clear when you set out the place value counters to work out the difference between each of the numbers. The first one we start with is 120. And then the second number was 135. So if we now look at the difference between those two numbers, we can see what's been added each time to get the next circle. So there's your 120. If we also remove the 120 from the second number, we can see that there's a 10 and 1, 2, 3, 4, 5 ones. So the difference between 120 and 135 is 110 and 5 ones, or 15. And then we can check that. If we had 135 and we add 15, 135 add the 10 would be 145, and then add 5 ones, 146, 147, 148, 149, 150. And now to get A, we'd add the 15 again. So 150, add the 10, it was 160. 161, 162, 163, 164, 165. So A is worth 165. And then we do the same with 165. 165, add the 10, 175, 176, 177, 178, 179, 180. And then there's 195. And then C would be 195, add the 15, 195, 205, 206, 207, 208, 209, 210. And then 210, add 15 is 225, 225 add 15 is 240, and then 240 add 15 would be 250, 251, 252, 253, 254, 255. So now let's go back to the problem. Kate said that she thought circle D was worth 250. Was she right? No. So Kate hasn't understood the difference between each of the circles and that the difference is the same each time. So hopefully you recognised that she needed to add 15 each time rather than adding on the 10. Well done if you got that right. Now let's try some problem solving. Millie and Jack started counting at the same time. Millie counted on in tens from 300. Jack counted back in hundreds. After 6 counts, they reached the same number. What number did Jack start counting from? I would draw this out. I think that's the best way to do it. Draw it out, have a go, and then pause the video and I'll come back in a minute with the solution. Let's read it one more time. Millie and Jack started counting at the same time. Millie counted on in tens from 300. Jack counted back in hundreds. After 6 counts, they reached the same number. What number did Jack start counting from? Draw the model, have a go. If you have counters, try and use those to help you. If not, I'll reveal the solution in a minute. How did you get on? This is a really good challenge. Let's see if we can work it out together. So we start, first of all, from 300. So there's your 300. Now Millie counted on in tens, and they did 6 counts. So there's count 1, count 2, count 3, count 4, count 5, and count 6. So there's her 6 counts, and she's counting on in tens. So it would be 300, 310, 320, 330, 340, 350, 360. Now we have to work out the next part, because Jack counted back in hundreds. Now, instead of counting backwards, we could actually count forwards to work this out. So if we start where Millie finished, so Millie's at 360, that's where they're both going to be. So we have 360. There's count 1 of Jack's, 460. There's count 2 of Jack's, 560. Count 3, 660. Count 4, 760. Count 5, 860. And count 6, 960. So Jack must have started at 960 and then counted back in hundreds. Well done if you worked that out. That was a good challenge. Let's finish with a bit of shape fun. Have a look at these shapes here. How many triangles can you count? Maybe use your finger, trace over the outline and see if you can count them. And then once you've done the triangles, have a go at this one. I'll come down a little bit so you can see it better. How many rectangles can you count? Again, maybe trace the outline, see how many there are. And then for a further challenge, maybe try one of your own. You could try all sorts of shapes. See if someone can work out how many you've got in your picture.